So the textbook book back first question, the swimmer goes from one bank to the other bank and comes back. This cannot be periodic because he might take different time to swim. A freely suspended bar magnet, when suddenly released, it tends to oscillate. It will be periodic but will not be simple harmonic. Third one, a hydrogen molecule rotating about its center of mass. Yes, it will be periodic but not simple harmonic. Simple harmonic is one which can represent it as a single sine or cos function. And or it has to be simple through condition A is equal to minus omega square x. Either it has to be obeying this condition or it has to be a single sine or cos functions, then we can say it as simple harmonic. An arrow released from the bow, no, it's not even periodic. Halley's comet is periodic, it occurs every 76 years, so that's periodic but not simple harmonic. Okay, let's go to next one. The rotation of the earth about its own axis. It's periodic but it's not simple harmonic. The YouTube manometer, the mercury column is going to oscillate. Obviously, it will be simple harmonic. We just learnt it in this lesson. Every simple harmonic is periodic function. So, periodic plus simple harmonic. Motion of the ball bearing. Okay, you put a goalie mari on a bowl. It tends to oscillate, right? So, it is periodic. It is also simple harmonic. Why? Because there will be a restoring force. As this goes up, the frictional force is going to bring it down, and so then that's also like a simple harmonic motion only. So the next one is the general vibration of a polyatomic molecule about its equilibrium position. It's not simple harmonic. Okay, they are vibrating. Each of its vibration is simple harmonic, but when they superimpose, you are not able to sum it up into one single sine function or cos function. Just mug it up. Okay, so let's go to third question. They've given a graph like this. This is neither periodic nor simple harmonic, obviously. Then there is this minus 1. It starts going there like this and then comes down and goes like this and comes down. One full oscillation. This is plus 1. This has taken one. This is definitely periodic because it's repeating. And the time period is 2 seconds from this graph. So the next one is a weird graph where it's all like this. So it's non-periodic and non-periodic. That's all. So the next one is a sine function, which is obviously a simple harmonic and also periodic. So every simple harmonic is periodic, every periodic is not simple harmonic. So let's go to fourth question. The fourth question has got a sine omega t minus cos omega t. So then you try to convert this into this is periodic because you take this omega is equal to 2 pi by capital T. Here also omega is equal to 2 pi by capital T. T is equal to 2 pi by omega, T is equal to 2 pi by omega. Both of them are going to ring together at the same time. And the combined function is also periodic, but it's not simple harmonic. To check simple harmonic, I have to convert this into one single sine function. Write it as 1 sin omega t minus 1 cos omega t, multiply and divide by a root 2. Root 2 into, this is cos 45 sin omega t minus sin 45 cos omega t. So that is of the form sin A minus B. You can write it as sin omega t minus pi by 4, and you manage to convert it into one single sine function. This is the maximum amplitude it's got, and so then therefore it is definitely simple harmonic. And what is the time period? It's got omega is equal to 2 pi by capital T, so it's 2 pi by omega, and that's about the time period. It's just one single function, and ting ting ting, the bell is going to ring, I'm saying. Okay, so this is the maximum amplitude. Okay, so let's go to next function. Is the sine cube omega t. And from sine 3 theta formula, you know it's 3 sine theta minus 4 sine cube theta. And what is sine cube theta? Therefore, is 3 sine theta minus sine 3 theta by 4. So put it here at 3 by 4 into sine theta minus 1 by 4 into sine 3 theta. See, the thing is, you can never convert it into simple harmonic function because the 3, 4 and 1 are not a triplet. 1, 2, root 3 is a triplet where this is 60 degree and a 45 degree. It's a triplet which is a part of right triangle. I can convert this into sine and cos and sine and get it into one sine function just like previous sum. The other triplets are 1, 1, root 2, which is what I used to 45 degree in the last sum. You also have a 3, 4 and 5 which can be triplet. We can also have a 12, a 5 and a 13 can be a triplet. So this is not a part of the triplet. So you can never convert this into one single sine function. So it's never simple harmonic. But It can be periodic because individually they are periodic functions. And so it's like 3 by 4. So what is this question? You have 3 by 4. Oh, so you just converted it like this. So the theta here is omega t, the theta here is omega t. So this gets like this, and omega is equal to 2 pi by capital T, 2 pi by omega. What about here? 3 omega is equal to 2 pi by capital T, because there is a 3 omega here. And omega is equal to 2 pi by 3 by t. Can you see? So t is equal to 2 pi by 3 omega. On comparing t1 and t2, can you see t2 is 1 by 3 of t1. 1 by 3 times. So at a common LCM time, both the functions will ring the bell at the same time. I am always giving this the bell as example. So then therefore, at some common time, say this is going to this class is bell rings every 60 minutes. This class bell will ring every 20 minutes, and put together both the bells will ring together in this now. So the net time period is 2 pi by omega. Therefore, combined function is periodic. Okay, but not simple harmonic. So let's go to next sum. Next sum is x of t is equal to 3 into cos pi by 4 minus 2 omega t. Just switch this, is cos of minus theta is cos theta. So 2 omega t minus pi by 4, and you got it in the form. And this is your initial phase, and this is 2 omega instead of omega. So 2 omega is equal to 2 pi by capital T. The time period is 2 pi by 2 omega, or a pi by omega is the time period. This is the maximum amplitude. It's represented as one single cos function, and your maximum amplitude is 3, and therefore this is simple harmonic motion. It's also periodic, and it rings together, and there's no together, it's just one single function, and it's going to ring at pi by omega time. So let's go to next sum. X of t is equal to cos omega t plus cos 3 omega t plus cos 5 omega t. In this omega is equal to this function 2 pi by capital T1. T1 is equal to 2 pi by omega. 3 omega is equal to 2 pi by capital T2. Capital T2 is 2 pi by 3 omega. 5 omega is equal to 2 pi by capital T3. T3 is equal to 2 pi by 5 omega. So all this will ring together at one LCM, right? Okay, just multiply every term with 15. So 15 into 2 pi by omega, and or do one thing. Can you imagine that all this together will ring in one time, because this is a smaller time, this is a smaller time, so this is a bigger time. So at some point of time, all of them will ring together. Okay, so that's about it. See, supposing this class bell is ringing every 15 minutes, this will ring every 5 minutes, this will ring every 3 minutes. So put together all the bells will ring in 15 minutes, right? The combined function is definitely periodic, and the time period, the combined function is this. But however, this can never be expressed as one single sine function or cos function, therefore it's not simple harmonic. Let's go to next step. Next question is an exponential function. Exponential function, you know that it is an exponential function. The graph is like this, and so then you know that the t it will tend to infinity. Anything that tends to infinity is never periodic, so it's non-periodic. So let's go to next function, which is 1 plus omega t plus omega square t square. There again it's an upward parabola where the t will tend to infinity. It's an open parabola. So then when anything tends to infinity, it cannot non-periodic. Okay, non-periodic. So let's go to next term. As the 14.5 question, where they have given various positions such as minus 5, plus 5. The point C here is at a distance 2 centimeter. There's a mean position O. There's a D and there's an E. And this distance is 3 and this distance is 4. So they're asking at A, and this is B. At A, what will be at the position A? What will be the velocity? Extreme position velocity is always 0. What will be the acceleration? It will be pointing directly towards the mean position. Anything taken in the right is given in the question as to be treated as positive. So acceleration is positive, directed towards the center, so it's along AO. The force will be same as acceleration, it's positive along AO. So at B, at this extreme position also velocity is 0, but however the acceleration will pull it towards in this direction. A is negative, directed along BO. Force is also negative directed along BO. So next is at O and is pointing towards A. Pointing towards A, at the mean position, the velocity is maximum and is negative maximum along OA, and with acceleration at the mean position will be 0. Okay, because there's no retarding force at the mean position, right? So retarding force is also 0. So that's what is happening at O. Then the question is about C. At C, where is C and how is it directed towards A? So there will be a velocity which will be negative CO. Acceleration will also be negative because it will be towards the mean position, right? So it's negative along CO. Force is also negative along CO. So next is they are asking about a position at D. At D, how is it directed? Directed towards B. At D, it's directing towards B. So that will have a velocity which is a positive velocity. The restoring force will also, the acceleration will also be positive because that is also getting directed towards DO only. Okay, the positive velocity is also along DO and the force is also positive along DO. So let's go to next term. Next is at E. Where is E? It's he is here. And how is it directed towards A, which means the velocity is negative. Negative velocity along EB. What is EA? EA. And what about acceleration? Restoring acceleration, it's going to bring it in the direction EO and it's going to be positive. Acceleration is positive, force is also positive along EO. So I'm sure you understood this tabular column. So let's go to next question. The sixth question. Which of this is simple harmonic? Anything which can be in this form minus omega square into x. So option number C is the only one where there's a negative sign and x here. So that's only simple harmonic. So that's completed. Seventh question. X of t is equal to a cos omega t plus phi naught. They have given at a time t is equal to 0. The position x is 1 centimeter. At a time t is equal to 0. The velocity is equal to pi. If you get differentiate this, you get this. First you write 1 is equal to a cos time t is equal to 0, omega will not be there, omega t will not be there, cos phi. So this is my equation. Now find velocity, let's differentiate x of t. You get minus a omega sine omega t plus phi naught. Okay, that will give me my velocity which is pi. But in this question they have given omega to be pi. To be very honest, when I did the question, I found that they have given pi per second. It should be radians per second. Then only I can take it as pi. They seem to be happily taking this as pi. Well, that is omega, isn't it? Okay, anyway, let me correct that mistake. I'll correct the question as radians per second. So in that case, this will also be 1. And at a time t is equal to 0, I'll get minus 1 is equal to a sine phi. So that is my equation 2. So then therefore, I'll get, I can take the 1 and 2 equation and square both sides. A square sine square phi is equal to 1. A square cos square phi is equal to 1. A square sine square phi plus cos square phi is 1. So a square is 2. So a is equal to plus or minus root 2. So you get the maximum amplitude. You got this amplitude using the given data. Root 2 centimeter. Next you want to find the phase tan phi is equal to b by a, or tan phi is equal to, okay, you can divide 1 and 2 to get tan 2 by 1. You get a sine phi by a cos phi is equal to minus 1. Tan phi is equal to minus 1. Shows that where will tan be negative? All school teaches children in the second and the fourth quadrant. Pi minus pi by 4, which is 3 pi by 4, and a 2 pi minus pi by 4, which is 7 pi by 4. These are the three values. So you know the phase can be a 3 pi by 4 or a 7 pi by, initial phase can be this or this. I get one of this. Okay, then what is that? That completes the first question. The part A. The part B, they have given another one, which is x of t is equal to b sine omega t plus alpha. And at a time t is equal to 0, x is equal to 1 centimeter. Same thing. At time t is equal to 0, velocity is also pi centimeter per second. Angular frequency, again, it's pi per second, which is hertz is what is given. But however, they seem to be substituting in omega directly. And I have an issue with that. So I'm assuming that it's radians per second, and then I can substitute. So just take it and write it. 1 is equal to b into sine of t becomes 0, and so you get sine alpha is my first equation. The second equation is pi is the velocity, but you should have differentiated this. You get plus b omega into cos omega t plus alpha is my velocity. This is my velocity when I differentiate. It's positive. So plus b omega, time t is equal to 0, this component will not be there, omega t. So it will become just a cos alpha. And they seem to be writing omega as pi, for which I do not agree with, but it's okay. So then squaring both sides and adding it, you get b as root 2, just like root 2 centimeter, just like the previous method. And you divide 1 by 2, you get tan phi, which is also 1, which shows that it's pi by 4, or it can even be third quadrant, pi plus pi by 4, which is 5 pi by 4. The initial phase can be two different answers. So that's all. I've done that. Let's go to the next question. Is the 8th question. A spring balance has a scale that reads from 0 to 50. Okay, you know that spring balance will be like this. There will be a hook and whatever. And that can read from 0 to 50 kg. The length of the scale is just 20 centimeter. So you can put a weight of 0 to 50 kg, and the scale has got 20 centimeter scale. Okay, so a body suspended from the spring, when displayed and released, it oscillates, right? With a period of 0.60 seconds. The time period has been given. What is the weight of the body? So I hope it's recording. What's the weight of the body? Once again. You all know the formula for time period is 2 pi into root of m by k, where k is the spring constant. Have they given force constant as string constant? If they're not given, what you should do is F is proportional to x, F is equal to k into x. So k minus sign, k is equal to F by x. Do you know the displacement and you know the force? You know, for the maximum weight of 50 kg, the displacement that can happen in this length is 20. So can I take that and write it? Can I write it as 50 to be the weight? But this is force into gravity, so 9.8 or 10 by the total calibrated reading through which it can go down is 20. So I get 25 to be my k. So but the x is given in centimeter. This is in 10 centimeter, but the mass is in 50 kg, right? So then convert centimeter into meter and take it up. So this is your k. Once you get your k, you can plug this in here, and you want to find the actual mass. Okay, for this time period of oscillation 0.6, what will be the mass? By k is 2500, substitute, cross multiply, get your answer, and that's about it. Okay, so let's go to next question. It's the 9th question, where they have given a spring like this, and there's a mass m. The spring of force constant k is equal to 1200 Newton per meter is molded horizontally on a horizontal table. A mass of 3 kg is attached to the free end of the spring, pulled sideways to a distance of 2 cm and released. What is the frequency of oscillation of the mass? What is the maximum acceleration of the mass? If you know the time period, you can find the frequency. And what is the maximum acceleration of the mass? If A is equal to minus omega square x. Okay, we can do all that. So what is the maximum speed of the mass? The maximum speed can be occurring only at the mean position. These are the things, when you read the question itself, you should assess the question. Okay. What is the frequency of the oscillation of the mass? First question. If you know the time period, you can find the frequency, correct? Okay, next is what is the, you know the formula for time period. Time period is equal to 2 pi into root of m by k. So then you find the time period, 2 pi into root of m has been given to be 3 kg. By a force constant which has been given, the spring constant is 1200. So thus you find the time period, and the reciprocal this value, you obviously get your frequency. So this will be t is equal to 2 pi into 1 by 20 or pi by 10. So frequency will be 10 by pi. Okay, that will be the hertz or per second answer that you can write for the frequency. First question is answered. Second question, they're asking what is the maximum acceleration, and you guys know a is equal to minus omega square x. X is 2 centimeter, which you can convert into meter and write. Omega, if you know this, you can find omega. 2 pi mu is what is omega. So 2 pi into mu is 10 by pi. So 20 radians per second is my omega. So this substituting, you get 400, and xc is 2. So it's minus 800 is what I get. But it converted into 10 to the power minus 2, so it will be 8 meter per second square. You can ignore the acceleration, retarding acceleration, which is going to bring it down to the mean position only. So it's okay, just write the maximum acceleration. And so then the maximum acceleration occurs at the extreme position, right? Yeah, and that's why you took this 2 at the extreme position. You took this x as 2 and you did it. Okay, so let's go to next. Maximum speed they're asking. The maximum speed is always from the graph itself I taught you, it's plus omega into a is the maximum velocity. Yeah, so you know that amplitude. Do you know the amplitude? Amplitude is the extension with which you have extended, which you can take it as 2. Okay, so then 2 centimeter, 2 into 10 to the power minus 2. Omega you found out to be 20. So it's 40 into 10 to the power minus 2 is 0.40 meter per second is the maximum acceleration. Omega into a. Okay, we know from the graph, right? The maximum acceleration is omega into a. The maximum velocity is omega into a. The maximum acceleration is omega square into a. The a gets replaced as x, and here the 2 is the extension. So you know all this. Okay, so let's go to the next question, which is the 10th question. Let us take the position of mass when the spring is stretched at x is equal to 0, and the direction from left to right as left to right is positive. That's how we do every time. Give x a function of time for the oscillating mass. If at the moment we start a stopwatch at t is equal to 0, the mass is at its mean position, maximum stress position, and compressed position. At mean position, how do you write the simple harmonic motion? X is equal to a sine omega t. At the extreme position, you all know x is equal to a cos omega t, but x can be positive and negative, so they're including a plus or minus. And from this above equation, from the two above equations, they're asking you to find mean position, maximum compression position. What is that they want you to find? Maximum stretch position, maximum compressed position. You're supposed to write the displacement, the equation of simple harmonic motion, or displacement x. Okay, for which at a time t, let's take at a time t is equal. Do you have the amplitude? Has the amplitude been given in the question? No. So you know that x is equal to a sine omega t, and that is for starting from the mean position. And omega is amplitude is 2. Where is it given that amplitude is 2? At a time t is equal to 0, it is starting from the mean position. T is equal to 0. X will also be 0, right? If I'm starting from the mean position, if you're going to write x is equal to a sin omega t. 1 second, hold on. Oh, this was a continuation of a previous sum where you already know that the amplitude is 2. So then they are plugging in the value, and they know omega is 20. So just plug in the value. It's a continuation of previous sum, just plug in the value, that's all here. Okay, similarly here also plug in the value, thus you get the plus or minus, and you know that is amplitude is 2 and a cos 20t. It's the same expression. You're plugging in the respective value based on the previous question. That's fine. Now for the maximum stressed position, at t is equal to 0 when the mass is at the extreme position. And that's what is this. And I've written this also. Now at what is that next question? Second two questions over. T is equal to 0 when the mass is at the maximum compressed position. Maximum compressed position, which means they're talking about a block at T is equal to 0 maximum compressed position, which means your mean position, mean is here. Yes. Listen, this plus or minus is for the plus 2 cos 20t is for the right extreme position, which is the stretched position, and minus 2 cos 20t is for the compressed position. So we've answered both of this in this question itself. We put a plus or minus. The plus stands for the stretched and the minus stands for the compressed position. Okay, so that completes this question. I'm sorry, I didn't realize that's a continuation of the previous question. So next is the 11th question. Two circular motion, the period of revolution, the initial position, sense of revolution, or indicated. Okay. Obtain the corresponding simple harmonic motion of the x projection of the radius vector of the revolving particle p in each case. Okay, they have given this diagram where the revolving particle is here. Can you see it's come like this? So they've given the time period of this is 2 seconds. Okay, they've given the time period is 2 seconds. What else is the information that's been given? The radius or the amplitude is 3 centimeter has been given. You know that this is how you're going to draw it because it's going to approach to the, this means it's approaching the left extreme position. It's approaching. So correspond at a time t is equal to 0, where is the needle? I really want to understand the diagram. Diagram is not unclear. Because I need to find the initial phase and everything, right? To circular motion. So they asked for the initial position. Yeah, the radius of the circle. Initial position has been given. Huh? Oh, they seem to be saying this is the initial position, t is equal to 0. And this is p dash, which is the final position. It's approaching like this. The total time period has been given to be 2 seconds. The total time period, that is given to be 2 seconds. Amplitude, you know. So you can always, you're gonna, this is where it starts. Okay. Let me, in this, they have given this to be, it's like this, a pendulum from the mean position is going towards the left first, which is never the case. We always take it like this, right? I think so that I will just figure it out. I think that this is theta, and you want this angle, and theta is equal to, omega is equal to theta into t. Theta is equal to omega by, okay, t, and t itself is given. Have they given the time taken? Capital T has been given. Okay. See, basically, this is the angle that's swept through from moving from P to P dash. I've written this theta. But I know this position, this amplitude is 3 centimeter, and I project this on the x-axis. I can find this angle, which is actually 90 minus theta. So I can only write from this triangle cos 90 minus theta. Correct? Cos 90 minus theta is adjacent side. I don't know what is the adjacent side. Let's consider this is ON by the hypotenuse, which is 3. So ON is equal to 3 into cos 90 minus theta. So can I write as 3 into sin theta? Is ON, but since it's directed towards left, I can insert a negative sign here. So can I write x of t therefore is minus 3 sin theta. What is theta? Okay. Theta is equal to omega into small t. Omega is itself 2 pi by capital T into small t. And capital T has been given in the question as 2 seconds. So 2 and 2 get cancelled, though pi t is your theta. So you can write minus 3 into sin pi t centimeter. This is my x of t. Okay, there is, they have obviously not included a phase. Can you see that they have not included a phase? What happens if I'm going to take this as the starting point? Let me try. Okay, the same sum. Yeah, at a time t is equal to 0, if this is a starting point, there's already a pre-existing phase difference of, this is the phase phi naught. Apart from this is moved in this direction to a point p dash from p, correct? So for this itself, so we'll write normally x is equal to a sine omega t plus phi naught, and phi naught itself is pi here. I'm just trying to explore again, okay? So the thing is, this is your omega t, and to find that you can use this small triangle where you can use this cos theta is adjacent by hypotenuse, which is 3, or you can directly write this a is 3 sine what is your time period, they have given the time period omega is equal to 2 pi by capital T. Capital T in the question is 2 seconds, 2 and 2 get cancel, omega itself can be written as pi, and then the time at any instant has to be t plus a phi naught. In this case it's pi. Sin pi plus, in the third quadrant, all school taught your children, so it's got to be a negative. So you could minus 3 sin pi t. This is a better way of doing than what Aurora has done. Do not go by this method. This is fantastic. Let's always treat this as the origin. As the mean position and the projection is done. So you get to understand this phi naught is pi. And in addition, it's moved through an angle omega t. You get a beautiful answer in my way, which is perfect because that's a way we can't be changing our method every time. So let's go to next one. And next one has got this diagram wherein they have put time is equal to 4 seconds and this is 2 meters. And what else? Starting, they have given this to be t is equal to 0, and I hate this because at time t is equal to 0, it's supposed to be in here. So already there's an angle of 3 pi by 2, which is your initial phase. And from here, it is moving in this direction, it seems. It is moving in this direction, so your phasor is here. Okay, let me explore again. I'm only exploring. When I explore, I'll do 2 different methods, and I will do one. I'll look at Aurora. One, I'll do it on my own, and we'll figure out which is better way. So then this is the point, and this is the angle through which it's rotating. So let's consider that this is your omega t. The whole angle is 3 pi by 2, which is a phase angle. So would it be this is 3 pi by 2, and this is omega t. Since it's rotating through like this in this way, so I should be writing 3 pi by 2 minus omega t. So let me write it. X is equal to, what is this? It is again x is equal to, in this case, should I take it as it's coming from the extreme position, and because it's directing towards the center, so it's coming from the extreme position. Can I take it like this? And so can I write x is equal to a cos omega t and write a phi naught with it? I'm just trying, okay? And the phi naught is a 3 pi by 2. The full phase is here, the omega t is here. It's starting to rotate in this direction. See, I'll approach it my way. I don't want to copy from Aurora. I just tried and I'm getting the answer in my own way, like how I taught you. The needle was here at a time t is equal to 0. Now the pointer has come here, which means the initial phase was 3 pi by 2. Starting from the mean position, we'll always take x is equal to a sine omega t plus phi naught, where the initial phase is 3 pi by 2 starting from this position. So then it's a sine omega t plus 3 pi by 2, and it's 3 pi by 2 t plus, but here it's a sine omega t plus 3 pi by 2, and this is coming in the fourth quadrant. Sine the fourth quadrant is anyway negative. It should come in the third quadrant, so ideally you should have minus 3 pi by 2 or a minus omega t up plus 3 pi by 2, because this is rotating in this direction. Okay, you take it like this, and what can you say that it's going to be sine odd integral of pi by 2, so then it will be minus a cos omega t. And what is a from the question? You know the radius is 2, so minus 2 cos omega t. To find what is omega, the time period has been given. Omega is equal to 2 pi by 4, so pi by 2, so minus 2 cos pi by 2 into t, and that is the value of my x of t. That's the way I would write. I would not use Aurora's method. I hope you're clear. In both the sums, I don't want to do Aurora's method. I'll find the initial phase. I use x is equal to a sin omega t. When the initial phase, the first case was a pi, and sine pi plus is an even integral, while sine will remain sine negative, and I got the answer. Okay, and in the next one, I know the initial phase is 3 pi by 2. So when I still have considering mean position as only this, and so then therefore it's still the same, and starting from the mean position only I'm doing this sum, and so I get this answer. It's beautiful way, and I hope you're clear. If you're not clear, you can ask me. Let's go to 12th question. It says x is equal to minus 2 sine 3t plus pi by 3. Plot the corresponding reference circle of each of the following simple harmonic motion. Indicate the initial point, radius, angular speed. Sense of rotation may be fixed as anti-clockwise in every case. Okay. So they're asking us to keep the sense of rotation to be anti-clockwise in every case. In this, the initial phase is pi by 3. It's a sine graph. Correct? And x is negative. So you know that this is starting from the mean position only. Okay, and considering that the initial phase is pi by 3, which is 60 degree. So there is an answer which is negative. So in the previous sum, when I got an answer which is negative, I wrote it as an odd integral multiple, no, the previous step. So this should have been an odd, can I assume that this could have been an odd integral multiple of a cos, that is why it's become a sine. Can I just take it as it could have been a 2 cos 3t plus pi by 3 plus a pi by 2, because a cos 90 plus theta will be definitely minus sin theta in the second quadrant. So if I write it like this, and these two will be a pi by 3 plus pi by 2, which will be 6 into 2 into 3. Can I write 5 pi by 6? So it will be 2 cos 3t plus 5 pi by 6. So what is 5 pi by 6? It's actually 5 into 180 by 6. It's 150 degree. So this is my phase angle. So I'm just thinking that could be my phase angle. And if I'm going to draw this, a 150 degree should have been my phase angle. Where would the 150 degree be? Or a 5 pi by 6 be? And this is a cos function. Remember that. Initially, it's a cos function. The initial cos function means it should start from here. This is the starting point of a cos function, that is extreme points. Okay, when it starts from the mean position, we take this as a starting point for sine functions for the mean position. For the extremes, this has got to be the starting point. So considering that is a starting point, I will assume that 5 pi by 6 is 150 degree. So this will be my initial phase, which is 5 pi by 6, which is my phi naught, which is the initial phase. After which, so that this is where t is equal to 0, my needle is. And I do this diagram and I get this. And what other thing has been given in this? It's given that omega is 3. You know, omega is 3 and the amplitude is 2 units. Omega is equal to 2 pi by capital T. So T is equal to 2 pi by omega. So T is equal to 2 into 3.14 by 3. Whatever seconds that is, you can find the time. I don't know if they're asking you for the time. They're just asking you to draw, and I've drawn it. Okay, so first one, the amplitude is 2 units. Yes, omega is 3 radians per second. Done. And the initial phase is 5 pi by 6. And we also wrote the expression for it. We also depicted it. Beautiful. So lovely. The moral of the story here is you should understand, so far we were doing that it's all going from mean position. We have never done anything from the extreme position. In the extreme position case is where we studied the theory in which we write cos omega t, a cos omega t. That's for this position where it keeps going like this is your phi naught and this is your omega t. I'm sure you understood that part very clearly. So coming back to next question, it's the second subdivision. X is equal to cos pi by 6 minus t. So there's a graph like this which is cos pi by 6 minus t. Normally it's omega t. Can we switch this? Am I allowed to switch this? X is equal to cos of t minus pi by 6, where omega is 1 radian, 1 radians per second. And have they given the time period for the, no, they have not given the time period or anything. Even for this you have to find the time period. So omega is 1, omega is equal to 2 pi by capital T, 2 pi by omega. So omega itself is 1. So 2 into 3.14, which is 6.28 seconds is my total time period. And okay, this angle has been, I've written as cos of minus theta, right? So which means the theta, the phi is become minus theta. Okay, so it's minus pi by 6 is what I get. The moment I get the phi to be minus pi by 6, I understand that in a phasor diagram, this is again a cos, which means I'm starting from the extreme position, correct? And it's moving through an angle pi by 6 like this. So I know that the initial angle, this is the initial point, t is equal to 0. And then this is my phase, which is minus pi by 6. And why is it minus pi by 6? Because my starting point is below it. And that's my understanding. And I've drawn the phasor diagram, and you know the amplitude is 1 centimeter. I found the time period and everything. Okay, so that's beautiful. Let's go to the next question. So the starting point for extreme, it's cos, it starts from here. For a sine, it has to start from here. Depending on that, we have to mark the phase. Initial phase. Okay, so let's go to next. X is equal to 3 sine 2 pi t plus pi by 4. I hope it's recording. Yes. Okay, this question, sine graph, no negative sign on all. Appa. So it's totally a sine graph only. And this is your omega. Omega is itself 2 pi. And 2 pi by capital T is 2 pi. 2 pi get cancelled. T is equal to 1 second. And you know the amplitude itself is 3 units. 3 meters, 3 centimeter, whatever the unit they have given in the centimeter. Then this is your phase, initial phase is pi by 4. And how am I going to represent this? And this is a sine graph where you know that the starting point of this phasor diagram is here. The pi by 4 is this, and so it's going to start from, so should I assume that this is pi by 4, and should I do it like that? Because it's 3 sine omega t plus pi by 4. In this sum, I have an issue. All these answers are correct, okay? In this, it's got a 2 pi, okay? When it's 2 pi plus in a sine, it will become simply sine. But this time, t could be varying. So we cannot predict anything with this. We cannot assume that this is, phase is pi by 4 here. We have to, in this kind of a confusing situation where it is already having a 2 pi inbuilt. In other sums you see there's only this is pi by 6. You didn't have an issue here. In this sum, the previous question you had this was just a pi by 3. But yet since there was a negative sign, you try to write it as a cos 90 plus. And in this sum, we have never come across a sum where there is 2 pi t. So whenever you have a 2 pi t, then you have to try to write it as cos and c, and you are getting the answer as positive because this is a positive 3 sign, correct? So since it's a positive 3 sign, so can I write it as 90 minus, because when I told you sine has to be written as cos as a 90 minus, so therefore can I write cos 90 minus 2 pi t minus pi by 4? And can I switch this now? Can I also, because cos of minus theta is anyway cos theta, so can I write 2 pi t plus pi by 4 minus pi by 2? Can I do that? And then 3 cos of 2 pi t, and you solve this, it will be supposing you want to solve this, what it gets you is 4 into 2. So you will get back the question, don't do that. So you have managed to write like this. From here you managed to write it as a cos, and you managed to write it like this. So let me solve a pi by 4 minus pi by 2 is 4 into 2. It's minus pi by 4, right? Yeah, you're getting a different phase. Can you see? The fact that it's minus pi by 4 shows that it has got to be here. This is what is minus pi by 4, and that's the initial phase. Which means this is the time t is equal to 0. Yeah. So basically in this, you have to get it in this form. In this sum, they for some reason converting the sine into cos. It's not because of the 2 pi, no guys. They have just converted into cos. And you know cos 90 minus theta will be sin theta. So they're writing it like this, switch it like this. So you get it's minus pi by 4 is the new phase. And that's for a cos graph. And the cos graph is from the extreme position. You know that from the extreme position is cos graph, and it's moved like this through this distance. So it's minus pi by 4 is the initial phase. So the starting point, instead of here is the starting point is here from the extreme position. I don't know why they have drawn this. I'll have to think over it, okay? Oh my god, guys, I got it. Because every other sum in the subdivision has got the final answer in terms of cos, right? Remember, we did the minus nala, we converted it into cos. So then again, next sum also, we did cos of minus theta and we converted into cos. So therefore, we have to compulsory convert into cos to understand and compare 3 cos functions. So therefore, I have to, for so long I waited to do this. So I didn't understand. I took it as a separate sum. I didn't think it was continuous. So you write it like this, you obviously get the t is equal to 0 at this point. It's done. So let's go to next question. The next subdivision. Oh my god. Is x is equal to 2 cos pi t. That answers it. Okay. I didn't see that it's all one question where you have to compare all causes. Okay. Cos pi t. And that shows that there is no phase difference. Okay. The fact that it is already is phi t is at the extreme position. So then can I just say that it's going to be like this, and this is the place where at time t is equal to 0, this is where it is, and you can take it as an anti-clockwise rotation. Every orientation is only anti-clockwise, that's what they have said, right? So everywhere you have to talk about only anti-clockwise rotation, and we understood it pretty well. Only one sum I struggled in between. I've taken a bit of time to resolve it. I was thinking, why the hell should I do it? I don't want to convert it into cos. I will keep it as sine, but how? You're comparing 4 needles and you're seeing the positions of all the 4, then all has got to be cos. I hope you understood. So I'm tired, guys. I have to continue to do from the 13th question. For every sum, please find the time period and blah blah, whatever they are asking, okay? From the 13th sum, Oh, there's just 13th till 16th, the three more sums. So let me do it, okay? It's okay. I'm becoming very tired, but it's okay. So shows a spring of force K clamped rigidly at one end and mass attached. Okay, another spring has got mass attached at both ends. Okay, yeah, between the masses they are connected. Spring is stretched by force free. And read the question. I'll also read the question and come back. Leave it, guys. I'm too tired, so I'll just continue this video later. Okay. I have another class for 11th now, 12th now.